Welcome back, ladies and gentlemen, for our last session of today. We have an excellent panel that will discuss further on the topic of sustainability in our Deep Thought block. Let me present you the excellent lineup we have here today. We have Rosengreen, Lorenzen, CEO of the Danish AM Hub. We have Markus Heering, Managing Director at VDMA for Additive Manufacturing. We have Melissa Orme, Vice President of Boeing Additive Manufacturing at Boeing. And last but not least, Dr. Philip Reeves, Managing Director at Reeves Inside. And of course, if you have such an excellent lineup, you need to have an excellent and spicy moderator. So please let me present the moderator of this panel here, Professor Dr. Janis Schleifenbaum, Chairholder of Digital Additive Manufacturing at RWTH Aachen. Johan, it's a pleasure to have you as a moderator. Hand over to you. Enjoy your session. Thank you so much.
Thank you, Sven. So, first of all, I'd like to, of course, thank you two guys who bring us a bit on, let's say, on a certain speed level into the topic of additive manufacturing and sustainability. And you pretty much put our eyes on the importance of that. Of course, I mean, today we cannot neglect anymore the importance of reducing CO2 emissions, thinking about how can we get, with a good understanding of a resource that we use. In general, manufacturing, I'd say, we're here at the home of the family, the AM family. So starting with the first question, and maybe that points out the first one for you, Melissa, but the other ones are well invited as well. How do you assess the current level of importance of the topic sustainability in the field of AM on a global level? Do you think it's rather high, so in a sense that we have to include measures, whatever it takes, into every single step that we want to take in the future? Is it that high, the importance? Is it medium, that are other topics as well, or is it rather low? We have to think about productivity, process stability whatsoever. How do you think, where is the right level for sustainability?
Well, this is my personal opinion, and I think it's high. We're at a really important part in this planet, really important time that we have to pay attention to what we do. And right now, it's kind of an experimental phase with additive. People are playing with machines. They're creating a lot of scrap. They're just, and I think we have to stop that. Yeah. And we have to just, use it as a tool and not as a toy.
Yeah, true.
Right? Yeah.
Agree. Frank, maybe your thoughts on that?
Yeah, so just echoing what Melissa just said, the conversation is there for sure. It is high on the agenda, but I think also there's a question around the maturity of the discussion, where I still think we're in a phase where in Denmark we have this term called the sticker phase, that you have stickers on everything and you say, I'm part of this, I'm part of that, and therefore I am. And that's not really helping anyone anywhere. We need to push real things out there. We need to bring the data and the proof that this is better than a traditionally manufactured product, part, or component. That's not difficult to do. And there I see a bit of lack in maturity. It's something we did in Danish AM Hub just the last year. We brought 15 small and medium-sized enterprises on board in our projects. We gave them DFAM as a tool, so design for additive. We created completely new parts, lighter, more optimized, and we've calculated all of them in terms of the carbon footprint. It's not difficult to do. It is expensive, though, let me tell you. But that's the road we need to take as an industry. There's often been this challenge against AM that it's a technology that hasn't found its problem. And I really hate that as being part of the family, right? True. I really hate that. Well, guys, the problem is right here. It's the climate problem. It's the CO2 emission. We have a technology here that can really reduce material. And we need to bring, I know it's not perfect. Everyone in the family knows it's not perfect. And we don't need perfection. We just need to be every day a little bit better than what is there today. And prove that with data.
Yeah, cool. Thank you. Phil, in a positive sense, you're an AM dinosaur. You know the industry quite well, I guess. And the interesting
in a positive sense.
Side story was that you two guys over there met in Austin, Texas, like in '96, and we had. But anyway, that's detouring a bit. But what do you think if you look back into your additive manufacturing career, not only Stratasys, what you do today, all the consultancy, all the things that. Is that really, is it there? Is it accepted that it's that high as the two others said, or what do you think?
we were just talking before. I came here, I've come here every year, but in 2009, I came here with a software company that we'd spent about £2 million developing an LCA tool for additive. And it fell off the edge of a cliff. Nobody was interested, nobody at all. You take an STL file, you build a virtual supply chain, you take a CNC machine part, you do 2 comparative LCAs. No one cared, no one at all.
Yeah.
We canned the project. Now, and I think the reason we canned the project was at the time, nobody was really interested in production. We were talking about production, but really we were just prototyping. Now we're here, and this Formnext is really different to others, that I would say there's more dominance here about process integration, automation, full shop floor end-to-end. And now's the time we can really talk about sustainability. Because we shouldn't be looking at an individual additive machine. We should be looking at the systems talking to one another and saying, how do I optimize efficiency? How do I stack flow my builds? How do I think of everything in terms of energy consumption and waste reduction? And actually, I think we can do it now. I don't think we could do it in 2009. So I think we're right at the right time to make sustainability a big part of the agenda. Yeah. And certainly environmentally and economically. At the end of the day, economics drives companies. And with the cost of energy, the cost of raw materials, we may as well make the most of it and really drive the sustainable agenda.
Yeah. Markus, I mean, you are heading the additive manufacturing working group at VDMA, and these are 3,500 companies or even more in Germany alone, 4 million of employees. What do you feel if you go to your members, and do they feel the sense of urgency as well? Is it rather high, low, in the middle? Where is it from your point of view and your members' point of view?
It's high. So I can confirm what the others said before. It's now on the agenda of everybody. And also, it's not just the society what is speaking about sustainability and what that means for them and for countries, for the world. It's also the customers coming with the questions to the suppliers and to the manufacturers. And they would like to know how sustainable is the product, how sustainable is the procedure, and you have to deliver information. You need data on that. So we have to work on that. And on the other side, I tried to mention that before in my presentation. The authorities have changed this point also. In 2009 it was not a topic, but now we see in Europe it's a topic with the Green Deal. In US it's a topic. It's funny, in India it's a topic. They have to deliver information on sustainability also. So it's a global challenge to deliver this data and this information. What I see on the other side, the challenge for the industry is, it's not the only one. The only topic what is important. We have others what are also important, and that's make it so difficult that we have to work on different tasks, simultaneous, and we have to find solutions in different tasks. But however, sustainability is on top of every manufacturer right now, in mechanical engineering, also in additive manufacturing.
And I heard that all throughout the show that this is not a problem that a single company or whatsoever can find solutions for. We have to collaborate. I mean, it's a bit like bringing olds to Athens, but there's quite a hype about additive manufacturing sustainability. But if we look at it at a more detailed level and take a closer look at the recirculation of materials, maybe there's not that good in terms of zero waste, zero energy. You said it, the best part that we have is the part that is not there. So there's always the sense of greenwashing in the air and just putting another sticker on that. Is that an appropriate assessment? Is that always logic in that step in that we are? And if it's not appropriate, what can we do to get over it? What do you think of that, Phil? Maybe you can start with that at first.
Yeah, I mean, I always come at things from the viewpoint you have to think of things in a full life cycle assessment. You can't just pick on the material is not sustainable, or the process is energy inefficient, or the distribution chain is too long. You have to look across all of it, and there are cases of, really awful materials being used in additive manufacturing that use a huge amount of energy, titanium, aluminium, just to get them out of the ground before you atomize them. They're not great materials, but we live with that, and we work in different ways to find more sustainable materials. But we offset that by doing fantastic part consolidation, topology optimization, weight reduction. We save fuel in aircraft. All those knock-on effects offset the fact that the material has a huge embodied energy. So I think we have to not focus too much on saying, oh, the material's not sustainable or not recyclable. Let's focus on the kind of the low-hanging fruit first.
Yeah.
Let's deal with inefficiencies. Let's improve utilization. And then when we've got that pinned down, let's then start moving on to more sustainable material.
Yeah. Maybe from a company perspective, Melissa, I think there's always a technical point of view that you have, but also I see, I mean, Boeing stock-listed company, and I see that capital markets also force us to do that. Is that helpful? And to what extent can we use that power that capital markets push on our technology and really bring things from a technical and business point together?
Is that for me?
Yeah, it's from, for you, for me.
It is helpful, right? I mean, any sort of push that we can get, it helps us. I mean, in terms of sustainability, it's the basic right thing to do, business case or not. But the business case helps. Helps our finance, focals at Boeing and so forth, right? But I wanted to piggyback off of what you said about, titanium's not the best material. Aluminum, we dig it out of the ground. But if we could make it with a fraction of the material that we used in the traditional, that we were making it anyway, that case study I showed, we were, hogging out a great big chunk of titanium before additive, and now we're just printing a smaller amount, right? So it's not perfect. It's not like 100% emission-free or energy consumption-free, but we showed it's about 35% of the energy, right, of the other. So, I mean, we do have to look at the whole end-to-end life cycle. Yeah, I mean, maybe actually the printer uses a lot of energy, but when you look at the machining, the hazardous waste, the water consumption, the transport, and then with additive manufacturing, it's very important in aerospace, more than others, that we want to make it lightweight to use less fuel, right? And so we have that big driver for additive to make it lightweight, use less fuel. The product becomes more sustainable than just the part and manufacturing of the part, right?
True. Thanks. Markus, I mean, in the end, a life cycle assessment means life cycle, so you have to look at the parts. It's a bit of a hard of a perspective for a machine tool manufacturer or an additive machine manufacturer, because you're just delivering the drill and not necessarily drilling the hole into the wall, which is decisive in the end. But what do you think can the machine builders, the machine manufacturers themselves, what can they contribute to that really being green from the very beginning on?
I think we need a very responsible way how we handle this situation, because we have to look in details, we have to deliver data and transparent information about the procedure.
Transparent.
And I guess also important is we shouldn't say in general additive is more sustainable than others. This is important, because if we do that, somebody will find out maybe another procedure is better, and then we have exactly what you said before, greenwashing. Then we stand there and we will never come back from this point.
True.
So I guess we need an open discussion within the industry. It's a typical job for the associations where we can involve all the different parties, and then we have to deliver the information, what are available, what we need. If we need some research, we have to do that, and the transparent data is the basis for the discussion. And we need, of course, some more data than we still have today.
Frank, from a perspective of a country that is rather small, not many resources in there, somehow comparable to Germany, we have also none of the resources. The resource we have, we don't use anymore for good reasons. What do you see are, if you look into your community, what are good examples where additive manufacturing can be a decisive game changer? Are there any ones, and how do you get them? How do you get really into those examples?
Yeah, first of all, I would challenge a little bit. I would say in Denmark, actually, we have a lot of resources. One of them being green energy.
Yeah, sure.
Which I know pretty much every nation is envious of right now. So yesterday we had a bit of a storm in Denmark, and when I printed something in my basement, and that material was compensated, so the material provider would tell me, that's a whole other discussion, but would tell me that that material is CO2 neutral. And the print in itself, yes, the printer uses a lot of energy, but it's actually, when I had the product in my hand, it's actually close to CO2 neutral today. So it is something that we have because we have a lot of resources in Denmark, and we have a lot of skilled people and producers with this. Now, coming back to which application or which sector. We have in Denmark, we have 10 really, really large producers like Novo Nordisk, Danfoss, Grundfos, Lego, Velux, and some of the Coloplast and the rest. And then we have a jungle of small ones. And what excites me is when the small ones, they really get this. Because that's also kind of a confirmation that additive is really on the roll. We don't have a car industry like you have in Germany, but we have 400 suppliers to the German car industry, and they are competing against Chinese manufacturers or American manufacturers. They are actually doing a really good job because they are finding a niche. They're finding a niche and a specialty that only they command. And when they start also using this new fantastic tool that additive is, they create more jobs, they create more value. So that's just one example of how this great nation that Denmark is, with all the resources that we have, how we find these niches and these expertises and build wealth from that also with this new technology.
Yeah, maybe directly jumping on that, by the way, I just wanted to say to the audience, if there are questions, don't hesitate. I see other AM dinosaurs here as well. So feel free to answer questions, to ask you questions. But I want to jump on that. Do you have any precise examples out of your community where you see that AM is really a topic, AM sustainability is really a topic that was integrated into some sort of other projects and where it gained importance that you really can feel, and it gave a positive outcome as well. So it was not only pain, but it was also success, because we heard there are many problems that we have to solve, and it's always a bit of pain, right?
Yeah, yeah, I do. Typically, the producers that we talk to, typically there has to be a business case. Yeah. Typically, still, you know, I wish that we could say, you know, we do this because it's more sustainable, but typically we need to find a business case. And obviously, just the one coming to mind is we have a drone producer in Denmark, and this drone is a really large drone, and it helps maintain wind turbine farms in Denmark and in Scandinavia. Just taking the hinge of this drone has 8 arms, and just taking the hinge there, and that hinge used to be manufactured with 4 parts, and because we can print it, it's just 1 part. And also, since we can use generative design, we can take a lot of material away, and that drone in itself is 11 kilo lighter because of that. Now, if you look at the production phase in itself, it's worse off to use AM because we're shifting from aluminum to titanium, and we are using titanium powder and a lot of energy. It's worse off. But if you're thinking of that this drone, the next 5-6 years, will fly up in wind turbines and can have a lot more load, and also has these 11 kilo lighter, so it uses less energy. That's really fantastic and amazing. Cool. But the conversation in manufacturing is not there right now. It's my, you know, it's my own personal opinion. People like us, like the Danish AM Hub, and we're a philanthropical fund with a little bit of money and a little bit of expertise. We have also to push this, prove this, and then bring the cases alive. And just going to our website, you can see 50 cases of how we've used AM in Denmark. And soon you will be able to open source see these 15 cases of Danish producers saying, okay, we want to share that, where also we have these carbon estimates.
One thing on that, is there a common DNA? What made a project successful? And maybe you don't showcase the ones that were not so successful. It's just a maybe educated guess. But what's the DNA behind it? How can we make them successful, and what should we maybe avoid?
Yeah, so I think also just echoing Melissa's presentation, when you work with these things, you start getting like a feel of the strategy behind when is it a good idea to print things from a sustainable point of view, also from a business point of view, but also from a sustainable point of view. And obviously we've built that into our projects, but even when we do so, sometimes we also get surprised that, okay, it wasn't actually a good idea to print this. And I think for us, since we're an open source, a philanthropical fund, it's easy for us because we'll just lay it out there and say open source, you know, we achieved these benefits in terms of maybe lead time or a better business case, but we did something that actually emitted more carbon into the atmosphere. And just being honest about that, think of manufacturers out there across the world, right? 31% of human emissions today are from how we make stuff, because the materials are so bad as they are. Let's just be honest about what we're making, so it's not a surprise about what is this? Where is the CO2 emissions from that? Where has this been produced? Why don't we know stuff like that? So just being honest about that conversation is something that I think we can drive forward.
And maybe transparent. Melissa?
I think if we're all transparent about when is it a good sustainability trade and when it is not, it will be more believable, will be more genuine, right? People won't think we're just greenwashing additive as the solution for everything. And we're finding cases where you shouldn't, print it. It uses a lot more energy and it uses hazardous materials, and we're going to publicize that.
Yeah.
It's balanced with the good ones, of course, right? And so that I think it's our job to teach people when it is a good time and when it is when you shouldn't, right? Otherwise we're disingenuine.
Yeah. It's about transparency along the whole chain, right?
Right.
I think also it's also about thinking beyond just traditional manufacturing applications. I've done some projects recently in fashion where we're using additive manufacturing to displace traditional supply chains. I did a great project a few years ago in the petrochemical industry, which kind of sounds a bit perverse. Yeah. But using additive for better heat exchangers that reduce the energy consumption of the process industries.
True.
Now that's kind of it's a different area. It's not weight reduction, it's not topology optimization, it's efficiency improvement. Yeah. And actually some of those gains can be enormous. And there's a huge environmental benefit. Better heat exchanging, even through to valves, better valve systems. Anything that takes energy away from systems has a knock-on sustainable benefit. Yeah. And I think we probably have an education job to do outside traditional engineering and maybe getting into the process sector, into the Six Sigma guys and saying, let's start looking at wastes within your business. Yeah. Not just your manufacturing waste, but your process waste.
Still, we have to drill it down to the process. Once we decide, okay, additive manufacturing is a sustainable option for production, still there are many different kinds of additively producing that. Yep. Different machines consume different energy. Markus, is there a need for also the transparency for the machine tool builders like we have with the washing machines, A+ and stuff like that? Do we need something like that? And is it helpful or is it not? Is it also greenwashing? What do you think?
Good question. It seems to be a good solution because everybody is able to see that. But we have seen that with the consumption products with A+ and so on, and at the end it was A+++, whatever, and then we reduced the system to a different
maybe we
step.
start at G also, H or whatsoever.
I guess for industrial products or for machines, what I used for industrial procedures is not the right answer. It's too simple, and as we have seen before, the challenge what we have is so complex. It depends on the product, it depends on application, it depends on the conditions where we use later on the product, where we produce the product, which material we use, so that we are in general are able to put a logo or a sticker on the machine and that's it. And then it's sustainable. That is also a good example for greenwashing because I guess it's not the solution. But because it's too complex.
We could do, there does need to be more standards though, and again, I'll come back to this. If you try and do an LCA, between two comparative metal additive machines, they both quote completely different sets of metrics for everything because they're trying to compete. So one will tell you build speed in cubic millimeters per hour, one will give you Z height. Right. Yeah? One will tell you what their maximum power consumption is when you turn it on at spike, and the other one will tell you what their steady state is. And there's no data because everyone does a data sheet that's based on metrics that benefit them. And actually, as an industry, what we should have is a regulated set of metrics for a machine that says steady state power, peak power, build rate for different materials. And okay, I know it's very difficult to do, but we haven't done that. Other industries have. They do have very comparable metrics that allow you to make a choice between the two vendors. But additive hasn't, because we're just too damn competitive with each other.
True. Melissa, you want to add something?
And then once we get to that point, and I'm assuming we will, where we have the data on all machines, we still, we have two different companies using the machine differently and getting very different results, right?
Right.
And we have to be smart as engineers to, do the proper nesting and maybe simulate the build so that we don't have to develop it 12 times to get it right, physically, right? So there's a lot of things that we can do as on the people end, to use the machines a lot more, to get a lot more efficiency out of them.
True.
Right? People don't, and so I like to think about like the energy use per part.
Yeah.
Not like the energy of the machine, right? Because if I put one part in there, or if I, I'm able to put 12 parts in there, and if I have, and then you have to look at the number of lasers, and so you'll say, well, that machine with 12 lasers has like massive energy, but if I can make all these parts a lot faster, then maybe there's a better trade. Maybe the energy consumption per part is lower than in a single laser, lower energy machine.
Yeah.
Right? So it really depends on how you use it.
Yeah.
But let me add, this scenario, what you mentioned before, is realistic. So if you're looking to Brussels, for example, here in Europe, that they create a sample like this, it's absolutely realistic, and therefore it's our obligation as industry representatives to push the industry in delivering dates, make the procedure transparent, and say we have to deliver the information and also tell them that it's the wrong way to go. Otherwise we could have a sample like that. And then
I know there's always the dispute between being precise and correct in every detail and being practically usable. I think that it's really like you cannot fulfill everything, and in the end you have to have something that is usable, although it may be not correct in every detail. But if you are correct and it's non-comparable, then you just end up in a mess and nobody's able to decide anything. That's the same what we do today with our. If you want to acquire, if you want to buy a machine, and you get the different quotes, they're all sort of different. But in the end, you have to make a decision. Yeah, and that's what is actually needed.
And also, I guess we all agree we have to be more sustainable.
Yeah.
As industry in general.
Yeah.
Right. So, and if you have then something what we have to fulfill, that we are on the market. The consequence is not automatically that we are more sustainable, but we have to do. Resources are endable, energy is endable, so we have to find more sustainable solutions.
Yeah. What I actually like about the discussion is it's not bashing the manufacturers of the machines, it's not bashing anybody who's then using that machine and producing parts, is that we can only solve this together. I think that's one of the key messages that I take away. Again, I look in the audience. If there are questions, pose them. If not,
I have a question for you guys.
Yeah.
Okay.
So,
you say we shouldn't bash people, but I'd rather. I think walking around here, you've got some fantastic industrial, genuine application use cases, and you have. I'm not going to say hundreds. There's probably not hundreds, but there are tens of vendors of low-value extrusion FDM who are creating thousands of tons of waste every year. Because what is being printed is Yoda heads, nodding dogs, and Eiffel Towers. And I wonder if that's actually going to give this industry a bad name.
Yeah.
So I'll put that to you guys.
This is when I was saying we have to use it as a tool, not a toy.
Yeah.
Right? And we just have to get away from that. It's still in the experimental mode. People are saying, gee whiz, we can make this, hollow Yoda head or whatever.
Yep.
But,
I would like to switch it a little bit because I said so many times, that was when we started this show 7 years ago. That was the case. Everybody shows these gimmicks. and you're not able to see any industrial application. If you now go around, you said that all before, we see a lot of industrial applications. We see real used products.
And good ones.
A lot of business cases. But of course we have still some what are not so far, or not able, whatever, let's say they are not able to show business cases, why ever. Maybe the customers are not allowed them to show, or they don't have.
But it's the right point.
But we're seeing more and more of them. I saw a low-end FDM machine in the middle aisle of Aldi. Yeah, and somebody's kind of going, Christmas present, and it's kind of, but why? So, and that to me, that just worries me a little bit in the back of my mind, that it could have a really negative impact on our industry.
Yeah, true. Frank, you wanted to add something?
No, I absolutely share that, and I think in Danish AM Hub, we said that there are many ways to use AM to benefit a producer, depending if you want to change your product, if you want to change your value chain, or if you want to do both at the same time. And if you don't want to change your product or your value chain, you can still get benefit out of AM, which is through tooling or prototypes, right? But to be honest, when you prototype stuff with a printer also, maybe being the next level from the Yoda heads, that's also just burning plastic, people. And we're really honest with them. We're telling, we have projects where we give them for free a printer for a couple of months, and we say, you know, you try this out, but we want you to change your product or your production line so you get into a more tailor-made system where you can get rid of material. That's what we want you to do. Or we want you to change your value chain. Look at your value chain. All your CO2 emissions is in your own value chain. How can you use this technology to get rid of that? Or create a completely new business model with your product, you know, with all the benefits that AM can give, where the customer can help you design things, you can have a really nice take-back order. Because that's the wave we need to broaden out there in manufacturing. I think if you just print a Yoda head, that's not okay. But if you print a Yoda head, and then you slowly get on to how to use AM for more benefit and more sustainability, it might actually be worth it.
Yeah.
It's probably worthwhile, you know, making sure that schools, you know,
for sure.
STEM understand this, because you see the cheap Amazon, you know, desktop polymer printer in, you know, every classroom, and they're really just, you know, playing, right? And so it's like, you know, that you have to stop playing and understand that every time you turn it on, you're using energy, you're using resources. You know, and that, I think that educational component needs to be there, which it's not.
Yeah,
I'm sure
absolutely.
it's not.
I mean, in one sense, simplicity is really good, and making the hurdles as low as possible that everybody can really play with. On the other hand side, if you point the finger in the mirror, it's pointing to you again, and therefore we need to have some sense of the urgency that we need to do something right now.
Yeah.
I wanna maybe we're already running out of time. We've got some more 10 minutes left. Maybe point also at a different topic, which from my point of view is not really discussed here and showed here at Formnext so much. And this is all about the recycling. I mean, we see new fantastic applications. Multi-material is a buzzword. But if I think of multi-material, I think of using it, it's cool. But if I think of recycling it, ooh. What do you think? How can we incorporate recycling? And is additive manufacturing in terms of recycling really some sort of able to be sustainable? What are your thoughts on that? Do you have any expectations or any experience on that?
I mean, it really depends on the material system, right?
Yeah. I mean, yeah, sure. Yeah. Polymer and metal on the one side.
So there's some, you know, companies that's, you know, kind of like all the rage. There's, you know, a startup coming every month that's taking scrap from titanium machine shops. Boeing makes a lot of scrap and turning it into powder. And some are better than others, and some even have, you know, yet to be vetted, a circular, you know, truly zero carbon footprint on recycling. You know, the scrap into powder. I mean, that's great. Other polymer systems, I'm not sure.
Yeah, I mean, from a polymer world, you know, we look at it that the greener the front end is, the better.
Yeah.
Right.
But as long as it's the right type of green. You know, growing castor bean oil to make nylon 11 is not great if you're displacing crops that are food-based crops. So you've got to look at that whole front end. Right. You've then got to look at the back end and say, well, can you compost it? Can you burn it? You know, can you reprocess it? In the middle, can we just use less of it? Can we do less prototyping? Do we really need to do 7 iterations when we can do 3 of them in simulation and do CAD? Right. So I think we're getting there. The problem is that we've spent a lot of time and money developing the materials we have, and a lot of time and money qualifying them for the hardware. Yeah. And then, yes, it's relatively, well, I wouldn't say easy, but it is. It's relatively easy to change the base chemistry of a lot of the polymers we use to make them more sustainable. But the cost of going through that whole process again and building value chains with a new material that's got 40% bio-based to it, that's expensive. So I think industry will drive material vendors to have more sustainable choices in polymers, but it's not going to happen overnight.
True.
But I think, you know, I mean, from my point of view, if I have, you know, some material system that I've qualified, and it has certain mechanical properties that meet the requirements of some engineering design, and another one comes on that you could say this has a fantastic sustainability story, right? Yep. There would be reason to invest in the requalification, from my point of view. That's something that I would actually support, because you know you want to be using materials that are sustainable, and you want to, you know, we as leaders need to set the example, I think, right?
And I guess one question is always, what's the value of the raw material? As higher the value of the raw materials, as easier will be the recycling. There is a must. If you use titanium or another a metal, what is very expensive, you will be interested in recycling, and it will be sensible to recycle.
Sure.
If you have a material where there's not a real value behind, so then we're speaking about polymers, it's too cheap to recycle, it's too expensive, and especially if we then have a multi-mix material, it doesn't make sense. And then we exactly at the point, is that really sustainable? Or is this a giveaway or a gimmick what we have better maybe not produced? It doesn't matter in which way, if it's additive or not additive. So this is the challenge what we have as industry in general, to take care with the product, the raw materials what we use.
Yeah, it's all about the internalization of external effects. So maybe we may or should give in the future also some artificial prices to that we can calculate it. I mean, in the end, the beauty of calculation in euro or dollar whatsoever is that makes it easy. We boil it down to one number and then we can decide. Again, it's either detailed or easy. Frank, any thoughts on that?
No, I just keeping it a little bit simple here. We've just, I think it's 9% of all the plastic that has been produced ever is what we've recycled.
Yeah.
The rest is waste on our planet.
And that the problem is there is no value behind.
Exactly. Yeah. So I think there has to come a change. You know, either politicians will do it, my children will for sure do it. Yeah. So there will be a change here, and AM suppliers will also need to look at that change coming and be ready for it. We've developed, I think the discussion around circularity is an issue that is best taken in terms of the whole manufacturing system, because it's the whole manufacturing. If you print something or cast something or mill something, you know, you should always use waste first.
Yeah.
Always. That's just a given, if you can. We have, just given you an AM example, we have a startup in Denmark who is printing 20 square meter homes for students using plastic waste and just strengthening that with a tree fiber. And he's built the printer himself in a large factory. And that's a new business model. And that is really hard because he's up against, you know, a really tough, efficient production system that knows exactly how to produce this, right? But these are the kind of models that I think we need to maybe foster, support a bit more, just to be sure that we can use all the waste that's on our planet still. Because that, you know, how can that disappear if we don't reuse it into products?
Yeah.
And we do have to look at the whole value chain. If I'm using a part on an airplane and it's made out of polymer because it's lighter in weight than something else, and so now that airplane is lighter in weight, so when I'm you know, flying it, I have less drag. I have, you know, I'm using less fuel. I mean, that's might, you know, really outweigh the fact that I'm using some material that's not that great, right? Because I'm actually getting a better sustainability trade from the operation of the lifetime of the airplane. It's better for the planet.
Absolutely.
Right? And so we need to look at the whole the end life cycle, not just creating the part and delivering it, but actually the performance and its life.
Yeah, true.
Right?
I think what's interesting is that once we talk about recycling, the natural reflex is that we think about recreating powders, granules, whatsoever.
Right.
But I think what's totally underestimated for additive manufacturing, old-fashioned, I would call it repair. Today we call it remanufacturing. But that still is a value. We don't need to have to go all the way to the smelter. We can use those parts again. And I think that's also totally underestimated, and that's additive manufacturing by itself. We just put some layers upon layers for the repair, and then we are there. I mean, it's a bit too easy again, but that is something that I see that it's also in there. I see the moderator too is there, so we still have some 40 minutes. Maybe
40 minutes?
if you have one wish for the future to be additive and sustainability being two sides of the same medal, what is the one thing that you would vote for that we need to have to make that happen? Somebody wants to start. One thing that we need to have to make AM sustainability being so close that we cannot detach them anymore.
I guess we need transparency, and we have, as an industry, work together, all with one target. Otherwise, we won't receive that.
And I was going to say education, which really goes education and transparency. I mean, and working together to educate.
Yeah.
Yeah, I think education and the right tools, the right life cycle tools embedded in the design, the simulation. Maybe that's what we need is our simulation tools to tell us what changes to our designs actually have long-term impact.
Right.
Now, whether that has a short-term monetary benefit to simulation companies, I don't know.
Yeah.
But in the long term, maybe people will pay for that.
Frank?
Yeah, I heard a colleague say that going to Formnext is like Christmas, because it's dark and it's cold and you'll never get what you really want. So I really want someone inside these great square meters here to come with these are the data behind the cases. This is my material, this is the transparency, this is open source. I'm just laying it out there so that we can really foster and bring this potential out of this technology. It just seems so obvious that this could be the production technology that we would turn to the next 100 years. But it won't be if we don't prove that it's better.
Okay, so Christmas is the right word.
Yeah.
I mean, the good thing about it is it's all there. Nobody mentioned something that's not imaginable. It's all there. So in the end, we all have to do it. And then I think that's the final message that we could send. We have to do it. It's work, but we have to do it. Thank you very much for being so discussive, for bringing your thoughts into that, and for maybe helping the one or the other to put his or her thoughts in a different direction. And maybe we'll see what happens next for Formnext, to have some transparency, to have more education, and then we take the next step. Thank you very much.
Thank you.
Thank you.
Big applause, ladies and gentlemen. Thank you so much to the five of you for this inspiring discussion. Very controversial. I liked it a lot. Thank you so much. See you at the fair. Ladies and gentlemen, that was the last point of our deep thought block today on day 3. Very exciting one. I have only one thing to be left for me. I have the pleasure to hand over to my colleague Frank Jablonski, who will have a very interesting guest at the afterwork session. Enjoy that and see you in 4 minutes.
Thank you. Thank you.